Hello, my name is Yang Li. I'm the AP teacher here. And today we're going to study about the higher order derivatives, okay? This is starting from here. Before we learned about if you have a function fx, right? And then you can find the derivative of this function. And if this derivative function also a function and differentiable, so you can do this function derivative again. So you will have derivative, you got second prime of that. There's one way to write this one. I'll keep going, right? So you're gonna have what? If it's continued differentiable, you're gonna have what? You're gonna have a third derivative, right? And also you're gonna have what? Fourth derivative. You're gonna have what? Fifth derivative, like this. It keeps going forever until they set f to the nth of the derivative, right? And the symbol you may write in different ways. You can write like this, as what I showed you here, right? And also you may write it as what? This, okay? Same symbol, right? Now let's look at the example 3.15. We're going to do the second derivative of this function by definition of the derivatives, okay? Remember at the beginning, we learned about the formula in the form of 3.6. We have, I put it here, okay? F derivative of x equals what? The limits h approach to 0. Fx plus h minus fx divided by h, right? Now, apply this one to here. You will see, you see 2, because this is 2x squared. This x squared will be substituted by this, x plus h. So that's x plus h squared, parenthesis, minus 3x plus h and plus 1. Minus fx, just this one, put it here, see that? Over h. So this one is direct application of the definition of the derivatives, right? Okay, after you got this one, we're gonna continue. Break this one down. So when you break this one down, let me just show you how I do more work here, okay? So make sure you understand. So we're trying to get what? We're trying to get fx plus h, okay? That's this one. So how do you find fx plus h? You just simply go by 2 times this one minus this one, right? Now, how do you get this one down? You can go like this here. This is 2 here. This part you can write it as what? X squared and the plus 2hx and the plus h squared, right? And the minus distributed in 3x minus 3h and plus 1, right? That's this part. And then you need minus what? Fx. Well, let me simplify this one first, okay? So this one you can get what? Distributing again. So 2x squared plus 4hx and plus 2h squared minus 3x minus 3h and plus 1, right? And then you got a minus fx. Fx is just simply go by this one, right? I put it here, okay? 2x squared minus 3x and the plus 1. So if you do the subtraction on the top here, what happens? This one's gonna cancel. This one's gonna cancel. This one's gonna cancel. So you have 4hx This is 4hx plus 2h squared. This is 2h squared minus 3h. That's why they got this one, right? I showed you the detailed steps. So when you listen to Miss Lee's lesson, you can see detailedly how each step's moving on, okay? Now, after that, you can see, right now you cannot put the h equals 0. Otherwise, the numerator and denominator equals 0. That's not good. So what you need to do is do the factoring, okay? So you do factoring at limits, h approach to 0. Before you substitute the h go to 0, you can factor the h out. So you're gonna have 4x and the plus 2h and the minus 3 divided by h. You see this h cancel. Then you can plug in h now. So when you plug in h, this here is 0. So that's why you got this. So this is the first derivative, right? And then we're going to do the second derivative. How do you do second derivative? You go this way here. Remember the formula? We still follow the same formula. Just think about this first derivative is the function. We're doing second derivative right now, right? That means you do what? This function, the first derivative function, and then derivative again. You just treat this one as another function, okay? You follow the definition of the derivatives. You got limits, right? H approach 0. You're gonna have what? F derivative, this function x plus h minus f derivative of the x. You just treat the f derivative as a function, right? It will be easy to think. And then divide by h. See here? This is the function. When you do derivative, it should be this function, x variable added by h, and the minus f, this function x over h, right? So you see here, this is the first derivative, that's the original function. Right now, when you do second derivative, here is the first derivative function, okay? Now, if you knew this, it would be easy. So I tried to put it here, okay? This one will be equals to limits, right? H approaches 0. And the f derivative of this one will be what? 4. Just plug in this x by what? X plus h, because this is the f derivative of x plus h here, right? So you got a 4 and the time by x plus h, right? See, that's what they got here, this one, huh? Actually, we're doing the same thing as what they're doing here. So, and then I'm gonna minus what? So this is minus 3, right? And then this is this part. And I'm gonna minus parenthesis 4x minus 3 over h. That's what they got here. See that? And then the rest of them will be easier. We just keep going from here, okay? From here, I'm going to erase this one first. And then we're going to start from here now. Let me explain this one. So you can go to here, you break it down. So how do you break it down? You go this one times this one, right? That will be 4x plus this one times this one. 4h minus 3. This one distributed in minus 4x distributing here plus 3 and divided by h equals to this is still put the limits there. You still need to put the limits here. So h approaches 0. Cancel first. 4x minus 4x, negative 3 added by 3 cancel. This h cancel equals what? 4. So that's why they got this one. Okay? So this is the way we do this kind of question. And this is, of course, you can keep going to the third derivative if the function available. Of course, this one third derivative is available because it's a constant. We knew that it would be 0. Okay. So let's go to this note here. We're going to explain how do the independent work here. I hope you do it before watch the following this video. Okay, I'm going to explain this one, and then you may pause it here and do it by yourself. All right. So we do this way here. We do f first derivative, right, equals what? Limits h approaches 0. You're gonna have fx plus h minus fx, right, divided by h, like this, right? And you're gonna have limits h approaches 0. And then this one will be x plus h squared minus x squared over h, like this, right? Substitute in, and then you will get what? This one, I still put the limits here, h approaches 0. This one you can write as x squared plus 2hx and plus h squared and minus x squared over h. And then you can do this one here. You can cancel this with this, right? And you can factor h out. So after you factor h out, you're gonna have 2x plus h over h. But you still put the limits here, h approaches 0. You see this will cancel. When h approaches 0, this is just 2x. We find the derivative now. This is f derivative of the x, right? And then we need to do second derivative now. Second derivative, you just treat this first derivative as the function. It will be what? F derivative of the x derivative again. So that will be limits h approach to 0, right? H approach 0, f derivative of x plus h minus f derivative of the x over h. Here we just treat the f derivative as a function and do one more derivative, follow the definition. So from here you can see that you will get what? Limits h approach to 0, because x plus h means this x substituted by x plus h. So you're going to have a 2x plus h and the minus fx, just 2x divided by h, right? Now you can break it down now here. So this one, break it down like this. So limits h approach 0. This one will be what? 2x plus 2h minus 2x over h. X cancel, and the 2h cancel. So you're gonna have what? 2. You see that? So we find the second derivative equals 2. Okay? Generally, we just follow the definition of derivatives. Do one first, got the first derivative, and then we go to do one more time to the derivative function, do one more derivative. So that will be the second derivative of the fx. Okay? You can go even further. All right? So if you have any questions, just please let me know, okay? So you may email me any questions you have, and I'll get back to you. All right? Okay, thank you. Okay.